Good afternoon, ladies and gentlemen. It's my personal privilege to welcome you all for this distinguished lecture series. We have the privilege of Mr. Padu S Padmanaban, former Program Director, SARI, and Senior Energy Advisor, USAID, to be here with us to deliver the distinguished lecture. Mr. Padmanaban, Padu as we call him, is a renowned expert on energy efficiency and allied areas and has played a very important role in accelerating energy efficiency in India through his services and expertise. He's one of the very few persons who have contributed significantly to the energy efficiency movement of the country. He has more than 4 decades of experience in designing of national, regional energy efficiency programs. He has contributed significantly to the power sector reforms and regional energy integration in South Asia, contributed to development of energy water nexus programs, clean energy and energy access projects, substantial contribution to planning and establishment of national and regional centers of excellence in energy efficiency and green. We from the Green Business Center had the privilege of Mr. Padmanaban guiding us in the initial stages of the formation of the Green Business Center. He served as the program director for South Asia Regional Initiative of Energy and senior energy advisor for USAID India's bilateral program. He's worked with several national and international agencies such as the World Bank, CAPSARC, AEEE, Altec Foundation, and several of them. Padu, for his leadership and contribution, has been recognized both at the national and the international level. Padu was recognized as the Regional Energy Manager of the Year 2019 by the United States Association of Energy Engineers. The IGBC had the privilege of having Padu receive the Hall of Fame Award in the year 2013. The World Clean Energy Award 2007 by the Swiss-based Transatlantic was given to him in recognition of his achievements in advancing energy efficiency and renewable energy. He also received the All India Power Award in 2010, the Energy Professional Development Award in 2008 by the Association of Energy Engineers India. Padu has been a felicitous speaker. He has taught at the School of Advanced International Studies, Johns Hopkins University, Washington, D.C. Padu has a bachelor degree in engineering from University of Madras and a postgraduate certificate in fuel efficiency from National Productivity Council India and diplomas in energy management from UCTI IRI Rome and ILO Torino. Apart from all of this, Padu has been a thought leader in energy efficiency and several of those related areas, an extraordinary communicator. Apart from thought leadership and communication, Padu also has a very unique capability of converting all his thoughts into action and in a very collaborative manner. We have had the privilege of enjoying the leadership and guidance of Mr. Padmanaban in the establishment of Green Business Center. Thank you, Padu, for being here with us to deliver this distinguished lecture. It's over to you. Thank you very much.
Good evening. I would like to thank CIIGBC for this opportunity and invite me, and especially thank my good friend Venkatagiri for his warm words of welcome and introduction. You really made me blush, Giri. Thank you very much. I am deeply aware that I am in a forum which has had renowned speakers in the past. People, a galaxy of speakers of eminence, and I'm both humbled and privileged to be part of that group. Given that the audience for this particular webinar is from industry, I thought I should focus on issues related to energy efficiency in Indian industry and what is next. That said, I would really like to begin with a historical context, the genesis of energy efficiency in India. Energy efficiency in India was actually led by the Indian corporate sector, and it was way back in the mid-60s when in Mumbai, the textile industry had a problem. They used coal, and coal has required a lot of space. So there was a premium on space in Bombay, shortage of space then, now for sure. And much of the coal, or in fact, all the coal was coming in by wagons from Bengal, Bihar. And there was a limitations on the number of wagons available. And that apart, the rail wagons had to negotiate the steep incline of the Western Ghats, and there used to be occasional accidents. And all of this actually proved to be a bit of a dampener in the receipt of coal by the city textile mills. And the textile mills were in a quandary and were looking for solutions. Around the same time, there were the two refineries in Mumbai, Esso and Burma Shell, and both these refineries had excess fuel oil. These are the heavy bottoms, and they had excess of it, and they wanted to market it. And what better than to market it to the textile industries who were their neighbors in Mumbai? But there was an issue here. At that time, in the early 60s, Indian industry had very little experience in the use of fuel oil. The preparation, the storage, the handling, and the combustion of fuel oil was something that Indian industry did not have much experience with. So the Planning Commission of India, when they were seized of this problem, they approached NIFES, the National Institute of Fuel Efficiency Services of UK, and inquired whether they could help them in advising Indian industry, particularly textile industry, on fuel efficiency and how to use fuel oil. The NIFES team visited India. They partnered with the National Productivity Council. They helped establish a fuel efficiency service within the National Productivity Council. And the NPC, together with the oil companies, began to provide the service to the textile industry in Mumbai and later expanded it beyond Mumbai. In 1973, when the oil price hike took place, the NPC's experience in fuel efficiency came in handy, and together with Indian Oil and Bharat Petroleum and Hindustan Petroleum, they provided fuel efficiency services to Indian industry at large. And this particular effort by these entities resulted in 1976 setting up of the Petroleum Conservation Research Association, or PCRA, who until even today provide petroleum conservation, strategic advice and services to the Indian economy. So between the periods between 1970 to 1990, the 2-decade period, terminologies changed. From fuel efficiency, we moved to energy conservation, to now energy efficiency. There was this 1982, there was this interministerial working group report on energy conservation in Indian industry, policies and programs. It's a very strategic report which provided a blueprint for how Indian industry could save energy. So during this 2-decade-long period, several lessons were learned, but there were two very important lessons. The first lesson was the establishment of fuel efficiency cells in industry, that is institutionalizing fuel efficiency or energy efficiency within an industrial complex. And this was done in a few industries, not very many, but at least a few stepped up to the plate and set up this fuel efficiency establishments within the premises. Hindustan Antibiotics, Hindustan Levers, Century Rounds, these were some of the companies who did so. And many of these companies also saved a significant amount of fuel oil. 20 to 30% fuel oil savings was registered. The other lesson was that energy audits began to be in fashion. In fact, Indian industry actually took to energy audits like a duck takes to water. And energy audits became quite popular, and the energy audit function also grew. But there were some mixed blessings in that, because as we all know, energy audit is not a destination, it's only a way station. It identifies energy efficiency measures, does not guarantee that they would be implemented. For implementation, you need a measurement and verification system, a before and an after. Energy efficiency cannot be metered. It can only be computed, for which you need a before and an after. You need an M&V system. And the discipline of measurement and verification took a while for it to develop. In fact, it did not develop in complement with the energy audit function. So there were some bumps along the way. But notwithstanding these bumps, we are today in 2021 at a fork in the road. And there are a couple of important questions that we need to ask. And there are specifically 3 issues which concern energy efficiency today. And they are, is it time now to reimagine energy efficiency and replace it with another coinage? As I said earlier, from fuel efficiency, we moved to energy conservation, to energy efficiency, and now is it time to move to another coinage? If so, what is that? The second issue or factor is it time to tap the core benefits of energy efficiency and use it to provide the persuasive arguments to press corporates and government to do more on efficiency? And the third is, how do we move from a unidirectional linear approach in the design of efficiency projects to a more integrated approach that can save 20 to 30% more fuel at the shop floor level? So these 3 issues or questions is what I would like to unpack with some solutions and answers. The first one is on reimagine energy efficiency. I would like to rephrase the question. Generally, we ask this question, how is energy used in industry? And the answer is pretty straightforward. You do an energy audit, you identify conservation opportunities, you rank the conservation opportunities, implement the measures, you save energy, end of story. Now, if you rephrase the question and ask the question, what is the energy used for? This is a very intricate question. It's not that simple to answer. What is the energy used for? And this question is important because what value addition can energy contribute to your enterprise? By switching from how energy is used to what is it used for, the goalpost has shifted. When you talk about the question of what energy is used for, then the answer lies in a different nomenclature. And this nomenclature is energy productivity. Now, energy productivity is the measure of economic growth or economic value from each unit of energy consumed either by a company or by the country. At the country level, it is defined as the GDP divided by every unit by the total energy consumed by the country. At the company level, it is the revenue of the company divided by the energy consumed in annually. And both the definition of energy productivity for a country, whether it's for a company or a country, requires an understanding of what it means vis-a-vis energy efficiency. Now, energy productivity, by the very definition and how I defined it, is focused on value addition. It is focused on value creation. Energy efficiency, on the other hand, focuses on energy savings. Energy productivity is strategic and seeks answers through modernization, diversification, and restructuring. Energy efficiency, on the other hand, is a tactical bottom line issue and contributes to cost reduction. Energy productivity, on the other hand, is a top line investment issue and directly contributes to revenues and profits. The challenge for Indian industry and for corporates is to transit from energy efficiency at the shop floor level to value creation through energy productivity at the board level. You need an industrial strategy that moves you from producing basic energy intensive products such as aluminum or steel or paper to high value products. For example, you move from aluminum ingots to manufacture of fuselages made of aluminum. You move from mild steel to manufacture of alloy steel, which is used in precision machine tools. You move from stationery paper to high quality paper, and so on and so forth. And there are examples in this country where this has been done. There was a paper mill in East India which was manufacturing stationery paper, and they moved to high specialty paper, and they improved the value addition threefold. There is this example of cement industry, which was making pozzolana cement, and moved to high specialty cement with much higher value addition. There's a petrochemical plant which manufactured nylon from caprolactam, but moved to high industrial fibers and high value items. So there are many such examples. Also, if you look at India, energy intensity in the industrial sector by and large is declining, is improving. So if that's happening in India and as also in other countries, so what's the problem? If you look at the G7 countries, especially the United States or Germany or France or Japan, here you would find that GDP per unit of energy has increased. GDP has increased, energy demand has declined or reduced in absolute terms. There's been an absolute decoupling of energy growth and GDP. In India too, GDP has increased, but energy consumption has increased, but the rate of increase of energy consumption has reduced. In India, it is not absolute decoupling, it is relative decoupling. Now we need to move from relative decoupling to absolute decoupling. We need a paradigm shift in how we view energy efficiency. Now, just bear with me for a few statistics. Between 1990 and 2015, in India, energy productivity improved by 78%. During the same period in China, it improved by 203%. Now, it's important to understand that the Chinese improvement in energy productivity was due to structural changes and value addition largely, and to some extent was based on shop floor energy efficiency. In India, on the other hand, much of the energy productivity improvement, although far less than what China had done, was largely due to industrial energy efficiency and to some extent due to structural changes. In fact, in India, our energy intensity on a year-by-year basis between 1990 to 2015 reduced by 1.8% every year. And energy intensity is the inverse of energy productivity. So energy productivity improved by 1.8% per year. But in China, energy intensity reduced by 5% every year, the largest reduction in energy intensity anywhere in the world, and much of it was due to structural changes. Now, that is important to note. Well, ours reduction was due to energy efficiency, but improvement in energy efficiency improves energy productivity, but only improves energy productivity marginally. That's very important to note. Improvement in energy efficiency improves energy productivity, but improves energy productivity marginally. The major improvement in energy productivity would be through structural changes and value addition, and the points that I made earlier. Now, this cannot happen overnight. The Atmanirbhar Bharat strategy for innovation in manufacturing to self-reliance and make in India is a step in that direction, could be a step forward. So this is the first point I wanted to make, that energy productivity is an important element and strategy to advance energy efficiency in the country. The second point is with respect to integrative energy efficiency. I've had several discussions with captains of Indian industry, and they have often wondered if they have achieved the full savings potential of the energy efficiency interventions and investments. The basic question is, can you save more energy than what you have designed your system for? Besides OPEX, can you save CAPEX? Besides bottom line operational savings, is it possible to simultaneously achieve top line investment or CAPEX savings? Now, if you were to map energy efficiency technologies and energy efficiency opportunities, you would have 4 quadrants. Quadrant 1 is well known. It is first aid measures, housekeeping measures, and I'm not going to talk any more about it because Indian industry is very, very familiar with that. Quadrant 2 is what I like to call as must-dos. These are energy efficiency measures. They are isolated measures such as waste heat recovery or combustion control or steam utilization and distribution efficiency or insulation. So these are specific standalone energy efficiency measures. And Indian industry has done quite a bit in that, and that's where Indian industry has largely been focused on. Quadrant 3 is integrative energy efficiency design approaches, and I'll come to that in a moment. And quadrant 4 is transformative technologies such as circular economy, digital manufacturing, nanotechnology, and so on. And quadrant 4 is still a little long term. It's not something that's going to happen now in the short and medium term. But quadrant 3 is where Indian industry is moving towards. In fact, is knocking on the doors of quadrant 3 and getting into integrative energy designs. What is integrative energy designs? It is advanced heat power cycles, cogeneration systems, pinch point analysis in chemical process industry, integration of pumping systems, and so on and so forth. There are water energy nexus kind of projects and so on and so forth. So that's where the Indian industry is moving towards. While quadrant 2, where they have all the experience, is energy efficiency projects structured around individual technologies. Quadrant 4 is, rather, let me step back from it. Quadrant 2 is individual technologies, but they do not include design methods that are inclusive. This is a very serious limitation in my mind on current energy efficiency design approaches, where diminishing returns limit us. What does this mean? It basically means, and I'm wearing my economist hat for a moment here, it basically means that when the marginal cost of an energy efficiency investment is greater than the value of the next incremental investment or next incremental savings, we stop, since we do not want to cross the cost competitiveness limit. It makes no further sense to tap further energy savings because it is not cost effective. But integrative energy design enables us to expand upon energy saving by another 15 to 30% more at a lower marginal cost of incremental investment and savings. The design approach is to tunnel through the cost effectiveness limit. Now, let me give an example. I mean, that will be easier to understand. Let's talk about a simple example which we in industry are familiar with, pipe insulation, steam pipe insulation. We know about minimum economic thickness of insulating wool. That's fine. But what about the rest of the system? The moment you reduce heat losses in pipelines, and assuming this is a very large chemical process plant and the steam losses are reduced, heat losses are reduced, you can trace it back to the boiler because you would have a reduction in the MCR of the boiler, the maximum continuous rating of the boiler. You will have a reduced size of the ID fan and the FD fan. In fact, the whole generating system would be downsized. Now, that's where you get your capex savings. That's where you get some of your energy savings too. The important point is that you don't select your generating system before you design your pipelines and your insulation. That is done first, and then later you trace it back to your boiler and all of that and downsize it accordingly. Let me give you another example. Big pipes, small pumps, or small pipes, big pumps. What do I mean by small pipes, big pumps? Generally in industry, the pipes diameter, if it is small, the friction losses are higher, the head losses are higher, the pump capacity to overcome those losses are greater, and hence you have a higher horsepower pump for a certain flow of fluid. Now, if you were to have a generous pipe, a larger pipe, then obviously you're going to have lesser head loss and lesser friction loss, and therefore your horsepower of the pump can reduce. So that's what I meant by big pipes, small pumps. Or if you don't do that, you have small pipes and you have big pumps. But the lesson here is, and I'm just giving it as a principle, the lesson here is that you do your pipeline design before you select your pumps. There are many, many examples of this kind. Let's look at a lighting example. You have, there's a lot of effort being spent in identifying a light source with the highest lumen efficacy. LEDs, an example. But when you really look at it, it's the task efficacy and the application efficacy which is as important as the lumen, the efficacy of the lamp and the fixture. In fact, you can have a high efficacy lamp and have a poor application efficacy, that is, the light doesn't reach the task needed to be lit up, and you'll have an overall inefficiency of the system. So clearly, you have to look at not only selecting of the right lamp, but also ensuring that the light from the fixture is used to light up the task required. So these are minor examples, but important that they are. Another way of looking at it is what I would call as the drill and hole analogy. We spend a lot of time in selecting a drill and selecting a drill bit, but spend very little time in identifying where do we want to put the hole, what should be the size of the hole, what should be the diameter of the hole, what should be the depth of the hole. And it's important really to understand that you have to look at things in a more integrated manner. The bottom line is that integrative design optimizes the entire system as a whole instead of its part in isolation. And in the process, could save you 10 to 30% more energy. Now I come to my last point. The last point, if you recall, I said that we need to look at the core benefits of energy efficiency. We need to look at energy efficiency not simply in terms of energy saved, but as the number of core benefits realized. This has been recognized in the building sector, and CIIGBC is very active in the building sector, and they know that. There is a strong empirical connection between energy efficiency and indoor air quality. There are positive impacts on health because of energy efficiency, because of improved indoor air quality. There are positive impacts on labor productivity. There's even some impact on absenteeism, that people like to be in the office and don't absent themselves from work. The corporate decisions on green buildings has changed. They no longer look at energy and water savings as the basis to go in for a green building. Some of these core benefits and the advantages thereof. But industry, by and large, has not recognized these core benefits to the extent necessary. One benefit which occurs every time efficiency measures are introduced at the shop floor level, particularly in engineering plants, is product quality. Product quality improves tremendously. There's improvement in employee motivation, employee morale, in industrial safety, in industrial hygiene, and so on and so forth. But there's also a macro level aspect to what I'm saying. And this is extremely important. It doesn't cover the industrial sector, but it's an important fact that there are macroeconomic benefits of energy efficiency beyond energy savings. And one of it is it can actually be a powerful tool to reduce the fiscal deficit of a state. I don't want to digress too much into this, excepting to state that power supply to agriculture in the country requires subsidization of the power. Farmers pay a subsidized power. And the subsidy is paid for or covered by the exchequer through a direct subsidy to the utility. And this contributes to some extent to the fiscal deficit of some of the large agricultural states in the country. 10 to 15% of the fiscal deficit can be on account of the direct subsidy paid for by the government to the utilities for the losses suffered in not getting the right prices from the farmers. So every unit of energy saved in agriculture through energy efficiency measures of pump sets and T&D loss reduction and so on and so forth can actually contribute to reducing the overall subsidy and therefore reducing the fiscal deficit. And more money now can be made available not to cover the losses in the power sector, but to the other social sectors like health and so on and so forth. So this was the third point I would like to make. Coming back, and I think I'm coming very close to my end, because I was told I have not spent more than half an hour. But in conclusion, climate change is a very difficult, dangerous, intractable, and existential threat to our country, to the world at large. And we all know the reasons for climate change. It's largely because of the carbon emissions which have taken place. And today, the world is moving towards, at least some of the countries are talking seriously about net zero buildings, net zero manufacture, and so on and so forth. If India is to move towards net zero, assuming you have a net zero India kind of a strategy, then energy efficiency has to be front and center of it. Clearly, energy efficiency is the bridge between a society or a country dominated by fossil energy as it moves towards economy dominated by renewable energy. Energy efficiency has to be the bridge. In fact, it has to be the first fuel. But for energy efficiency to be the first fuel, it is my contention that we need to look at reimagining energy efficiency as an energy productivity strategy. We need to tap into the core benefits of energy efficiency more than we have done so. An industry certainly can draw a lesson from the building sector in that. And we need to introduce integrated energy efficiency programs and approaches as against standalone energy efficiency measures that we have done so far, so that the system efficiency can improve and we can save 20 to 30% more energy than what we are now achieving. So with this, I will conclude. Thank you very much. Look forward to.
Thanks, Padu. Thanks for your address. I think you covered all the three areas very clearly with examples on the coinage of energy efficiency, work towards productivity, the co-benefits of energy efficiency, as well as looking at an integrated efficiency program rather than standalone programs. Thank you. Thanks for your address, Padu.